Have you ever wondered why a block of wood floats while a rock sinks to the bottom? Or why a helium balloon rises effortlessly while a basketball falls back to Earth with a bounce? The answer lies in a fundamental property of matter called density, which varies among different materials. Density is like a measure of how tightly packed something is, similar to how crowded a place can be. Imagine a suitcase. A suitcase full of clothes is denser than a suitcase full of feathers, even if they take up the same space. This is because the clothes have more mass packed into the same amount of space, making them denser. Density is all around us, influencing everything from the air we breathe to the objects we use every single day. It's a simple concept with profound implications for our understanding of the world. Understanding density helps us explain why certain objects float or sink, why some materials are heavier than others, and even how stars form in the vastness of space. So, whether you're a student, a scientist, or just someone curious about the world around you, understanding density is key to unlocking the mysteries of the universe. Buckle up, as we're about to embark on a journey into the fascinating world of density and its impact on our everyday lives. Now that we've established what density is, let's dive into the nitty-gritty of how it's calculated. Density is defined as the amount of mass contained in a given volume. In simpler terms, it's how much stuff is packed into a particular space. Scientists use a straightforward formula to calculate density. Density equals mass divided by volume. Mass is the amount of matter in an object, usually measured in grams or kilograms. Volume, on the other hand, is the amount of space an object occupies, often measured in cubic centimeters or cubic meters. Let's consider an example. Imagine a cube of gold that weighs 193 grams and has a volume of 10 cubic centimeters. To find its density, we simply divide its mass by its volume. 193 grams divided by 10 cubic centimeters equals 19.3 grams per cubic centimeter. This means that every single cubic centimeter of gold packs a whopping 19.3 grams of mass. While knowing the density of a single object is useful, it's often more helpful to compare the densities of different materials to understand their properties better. That's where relative density comes in handy. Relative density, also known as specific gravity, is a dimensionless quantity that tells us how dense a substance is compared to a reference substance, usually water. Think of it like this. Relative density is a measure of how much heavier or lighter a substance is than water. Water is used as the reference point because it's a common substance, and its density is easy to remember. 1 gram per cubic centimeter. To calculate relative density, we simply divide the density of a substance by the density of water, making the process straightforward. For example, the relative density of gold is 19.3. This means that gold is 19.3 times denser than water, making it very heavy. A relative density greater than 1 indicates that the substance is denser than water, while a value less than 1 means it's less dense. Section 4. The flotation factor, sink or swim. Now let's address the age-old question. Why do some objects float while others sink? The answer, you guessed it, lies in density. More specifically, it's the relative density of an object compared to the fluid it's placed in that determines its fate. If an object is less dense than the fluid it's in, it will float. This is because the buoyant force pushing the object upwards is greater than the object's weight pulling it downwards. Think of a rubber duck in a bathtub. The duck is less dense than water, so it floats merrily on the surface. Conversely, if an object is denser than the fluid, it will sink. In this case, the object's weight overpowers the buoyant force, pulling it down to the bottom. Imagine dropping a metal spoon into the same bathtub. The spoon, being denser than water, sinks straight to the bottom. Section 5. Density in action ships and sea creatures. The principles of density and buoyancy aren't just confined to bathtubs and rubber ducks. They play a crucial role in various real-world scenarios, from the design of massive ships to the survival of marine creatures. Take shipbuilding, for example. Ships, despite being made of heavy materials like steel, are designed to float. How is this possible? It all boils down to density and a clever manipulation of shape. Shipbuilders design the hull, the main body of the ship, in a way that displaces a large volume of water. By displacing enough water, the ship's average density, including the air inside it, becomes less than the density of water, allowing it to stay afloat. This principle is also evident in the natural world. Marine animals like fish and whales have evolved ingenious ways to control their buoyancy.